Hi, in our last lesson we discussed numeric expressions that involve taking numbers and putting operators, at least one operator with them, like a plus or a minus, a times sign or a division. Now algebraic expressions are set up sort of the same way, except that we use a variable. Now let me show you what a variable is here. Let's suppose that we have this line and it's divided up into 3 equal parts. And I'm going to let y represent the length of one of those parts. Now let's suppose that I wanted to know the whole length of this line. Well, we could represent it as 3 times y, 3 with a y beside it, or 3 with a dot and a y, or 3 with a y in parentheses beside it. Okay, so y is our variable, and it can stand for one number or more than one number. Alright, now let's take and look at some actual algebraic expressions. So we need variables, and we need one of the operators here, at least one. So here we have 1 plus 3y. Oop, I have to duck. Y is our variable. Now here we have xy plus 2, so we have 2 variables in this expression here. And our friend Euclid is helping us out again. Here is 10y divided by 2. Got a duck. Here's yet another example here. We have 2 variables, an a and a b, so a plus b minus 7. Those are all algebraic expressions. Now, let's suppose that I gave you an algebraic expression and I wanted you to evaluate it given what the actual value of the variable is. So, I want to let Professor Know-It-All explain this sort of thing. Now, he has come up with this miraculous invention whereby he turns a crank, and if you put in the numbers for the variables, it'll crank out the answer. So here's Professor.
Okay, Steve. Now, notice the front of the machine is our algebraic expression, 4x plus 2, and in this case we're putting in 3. As I turn the crank, notice the front of the machine changes. So we have 12 plus 2 in this case, and when I crank the machine I get 14 as my answer, popping out the right side of the machine. Now let's reset it. 8 minus 2a. A is our variable. We're putting in 3 for a. So we get 8 minus 2 times 3. Turning the crank gives us 8 minus 6. That's not too hard. Let's turn the crank again. 8 minus 6 is 2. Ah, good. That's right. Okay, reset again. Now we get 2 plus 6 over b. Put 2 in for b. So 6 divided by 2 is 3. And then we want to add that to 2. So we get 2 plus 3. Another easy problem. And let's see if the answer is 5. Yes, it is. Good. Let's continue on. My arm is getting tired, but I will go on. 2a plus 3b, 2 variables. A is 5 and b is 12. So we get 2 times 5 plus 3 times 12, which gives us 10 plus 36. Let's see what we get. 46. Right again. Okay, back to you, Steve.
Thank you, Professor. Now I'll do 2 more problems here, similar to what he was doing. Now here we have 16 divided by x minus 6a. Now let's take and put a 2 in for x and a 1 in for a. Now we get 16 divided by 2 minus 6 times 1. Now don't forget the order of operations that we learned in our last lesson. So we need to divide 2 into 16 first. That'll give us 8, and then we'll subtract the 6, and so we'll get 2. So in our last problem here, wherever you see an x, you put a 2. Wherever you see a y, put a 3. And now, the first part here, that's 5 times 2 times 2, which will give us 20. And then we got 12 times 2 times 3, and that will give us 72. And now, we got to remember, we got to divide 2 into 10 first, and that'll give us a 5. So start from left to right there, doing the adding and subtracting, and we get 92 minus 5, and that's your answer, 87. Thank you.